Martina, and today I'm going to talk about how to use machine learning to detect bad apples. And by bad apples, I mean macOS malware. So a little bit about me. I am currently finishing my master's degree, hopefully very soon. I am very interested in both cybersecurity and machine learning, and I really wanted to work on a project where I combine these two fields, and this talk is the result of that. And last year, I was a student scholar, and I'm so happy and excited to be back this year as a speaker. So this is the overview of my today's talk. I only have 15 minutes, so I can't go too much into details, but there is something that I can promise, and that I'm going to try to explain everything as understandably as I can. So first, I'm going to start with the problem that we have, and then I'm going to talk about the solution I created. Then we're going to look into the background of this solution. This involves the collection of the training data, the automatization, the data fetching, the pre-processing of this data, then which models I used, how I trained these models, then how I created a web solution, and I'm going to finish everything with a demo. So let's start with the problem. As we all know, manual malware analysis is time-consuming. It can take many hours, even days, to analyze some files. It involves lots of steps. A high number of files needs to be analyzed. It can be also a very complex job because, as we know, malware creators use various techniques to make this job harder, for example, obfuscation. And all of this then results in a delay in response. So here's the solution I created. And this is a web solution which uses machine learning to give us a prediction whether a file is malicious or not. The user of this solution, they just need to run the malware and collect the logs. This is a faster and more efficient way than the manual analysis. Also, this system can handle large volumes of data, and it's also user-friendly since it has a very nice, this is questionable, but I think very nice user interface. So let's start with the collection of the training data. First, we downloaded the malware samples from the Objective-C GitHub. Thank you, Patrick. Then these files were run into a virtual machine, and the logs were collected in a JSON format. Then we converted these JSON logs into CSV, and we labeled this data based on what we saw in the SPY3 tool. Thank you, Jaron. And all of this data collection and labeling was done by Daisy. So the whole process is actually automated, except for the data collection and labeling. This includes the pre-processing of the data, the training of the models, and the deploying of the final solution. I automatized everything with the use of GitHub Actions. Here we can see, overall, I have 3 pipelines. So the first step in the pipeline is the data fetching. I decided to store my training data sets on Google Drive. There is no particular reason why I did that. It was just very easy and it actually worked, so win-win. So my script checks every hour if there's a new data set available and only starts the rest of the process if there is. The next step is the pre-processing of the data, which is really crucial actually in the machine learning process because the raw data can often contain missing values or noise in itself, and we need to handle these. So the model needs to receive data that it can actually understand. So my pre-processing script, these are some of the steps it contained. An example of that is removing unnecessary features, or feature engineering, which means creating new features from existing ones to enhance the performance of the models. To manage the data, I use the platform DuxHub and DVC. These are created for machine learning projects, And in comparison to GitHub, so GitHub is very good to track version control code, but it's not really ideal for larger data sets, so that's why it's a better choice to use something like DVC. And now, when the data sets are ready, we can train our models. I use two models. The first one is a binary classificator, which gives me a prediction, more exactly a confidence score, about how confident it is that my file was malicious or not. And if this score is high enough, then the second model is triggered, and this second model is a multi-class classificator, which gives me a malware name. So here on the screen, we can see a screenshot from, again, the DuxHub platform, where I used MLflow to track all of my experiments. It also saves all of the testing results, and this allows us also to very easily recreate these experiments. So when the models are ready, they are also registered, again, on the DuxHub platform in the model registry. Now we can move on to the web solution. I created it very easily with Python and Flask. The models are downloaded from the model registry and used in the code. Then the whole project is packaged up into a Docker image and pushed to Docker Hub. And finally, I deployed the whole solution with the user render. Now here's the demo, where we can see that the user uploads a JSON file and clicks on the Get Prediction button. In the background, this JSON file gets converted into a format that the model can understand, and the user gets back first a confidence score about how sure the model is that it's a malware, and since the score is high enough, the second model is triggered as well, and we get a malware name. So I really hope that I was able to show you that using machine learning is actually not as scary as it might seem. There are some ways I think this project can be improved. One of them is it would be nice if the user can just upload a file, potentially a malicious file, and the log collection would happen automatically in the background. And the second thing, when I upload a larger file on render, it can take a bit long to process. So if anyone is interested in this project, I am going to make it open source soon on my GitHub, so you can follow me there. And thank you for listening.